So, good morning everybody. Welcome in the new year. Nice that you're here again this early on Monday. We're going to continue today. And these are the subjects that I want to discuss today. So first some things that happened the last few weeks in the Ethereum community. And then the main focus of today will be security. And first a part of security, and then the afternoon will focus especially on key management. Hi, good morning, welcome. So these are the main subjects for today: security and some news. Yeah, I don't know if you've noticed it, but YouTube has blocked some crypto content on YouTube videos. So that meant a lot of crypto-related YouTube videos were taken offline, but later on they were put back on again. So finally it ended up all right.
Why did they do that?
Yeah, they thought it was about mining crypto, and it was about doing scams and those kinds of things. But later they realized it wasn't really like that it was just educational content. But yeah, it's like a sort of a platform risk, so it's also important for us for the videos that we make. This video is also put on YouTube. So if it's all deleted, then that's too bad. But yeah, just to know that it happened. What also happened was the hack at the Maastricht University. I don't know if you heard about that. That was big in the news. So related to the security subject of today, that's also interesting to know. But not only did they have a hack, also the Open University turned out to be related to the Maastricht University. And on the Open University they have the National Blockchain cursus. So it's also educational content for blockchain. And I got a mail from the Open University that something wasn't reachable, the library. I think finally it wasn't really this content, but yeah, it's weird to know that due to a hack also things can be put offline. Do you need power sockets? Okay. Another weird thing that happened also the last couple of weeks was that the MetaMask mobile, that's what we've also been working with, the mobile on your on Android, that was also taken offline, and later on it was put back again, and they also were thinking that it had something to do with mining, but it turned out it didn't. Of course we all know that, but Google probably didn't know that. So there was also a lot of discussion about this. But it's also reverted, so that's positive. Another new thing is that there's a new version of Solidity, version 0.60. So that has slight differences compared to the 0.5 that we've been using so far. And even some of the examples that I've used don't work anymore with this version. So in one of the next lessons I will also detail the differences of this new version. It's not a big difference, but yeah, some minor things have changed and some improvements have been made. Now then there have been some upgrades of the Nodes software with some new functionalities added. There's been the Istanbul upgrade in the beginning of December. So then everybody had to install upgrade their nodes. Then it turned out there was a bug in the parity software. So that's one of the leading node software. So all the parity people who are all the people who are running parity software had to upgrade to prevent for a possible attack. It didn't. It was possible to send blocks to a node that were incorrect, and it started processing them partly, and then it locked up. And then there was a third upgrade beginning of January, and that was to prevent the so-called ice age. In Ethereum, we know that they are working towards Ethereum 2.0. Does everybody know that? No? Currently we are on Ethereum 1.0, and they're working on a new generation of Ethereum called 2.0. And in order to force everybody in the future towards the new version of Ethereum, they've made a sort of delay mechanism built into the Ethereum 1.0 that the block times are getting larger and larger and larger, and finally they go so large that it's impractical. So they thought Ethereum 2.0 would be ready by now and people would start moving towards 2.0, but it's not ready yet. So they had to delay that, the so-called ice age, to make Ethereum slower. So they delayed that with, I don't know, half a year or something. But they've delayed it a couple of times before, and I guess they will have to delay it later on. But then everybody had to change their node software again. And then also it turned out that one of the nodes called Nethermint didn't work, so there was a bug in that one, so that had to be upgraded also. So if you're a node operator, it was a busy month last month. So that was all the Ethereum news in the last couple of weeks. Okay, these are the subjects that we are working on. Today we have the security and key management, and next Wednesday we're going into testing. And I guess next week I'll explain something about Solidity version 6. And here we're going to discuss something about wallets. So these are the subjects. Then I just had a question about IPFS, and maybe people have been experimenting with IPFS and had difficulty to upload something to IPFS. Did you experience any problems with IPFS? Did you already try to upload something with IPFS? Some have. Yeah? You were able to do that? Sort of. Yeah, IPFS is a bit tricky sometimes. If you run IPFS on your own PC, sometimes it can take maybe half an hour or an hour until it's synced on your network. I really don't know why that is. But I noticed that if you upload it directly to Infura, then it's directly online everywhere. And here is a way to do that with a curl command and to the URL of Infura. And I've created a small batch file, I've put it also on the Slack. And you can drag and drop a file onto that batch file and then it uploads it. Because here you have the %1, that's the parameter of the batch file, so here it attaches the file. So you can also make other variations of this. Okay, now we're going into the security of Ethereum. As you know, it's quite important, that security, because there's a lot of value generally stored. And even even small bugs can result in the loss of your ether. So it's important to be quite aware of security. And yeah, the main thing that you have to just be aware of all the things that go wrong and take care of that, and use lots and lots of best practices. So that's a lot of detailed work to get it really super secure. So I'll explain a few things, but if you really go into production, you probably have to go even deeper than this, and for a big project, put a lot more attention into this and do audits and all those kinds of things. But I've collected basically two things. There's a weakness classification, so that's a sort of a list of all the things that can go wrong. And there's also a list of measures that you can take, and those two, of course, correspond to one another. And the main thing that I found is this one, the Smart Contract Weakness Classification Registry, this one, which is actually based on this one, the Common Weakness Enumeration. This is for general websites and other stuff, and this is more specific for blockchains, for Ethereum. So it's just a list of a lot of things that could go wrong. If you go to the site and click on it, they've for each problem they have examples. So that's also what I want you to do later on. Look at that and look at the examples, and if it's not immediately clear to you what's going on, just run it in Remix or whatever and experiment a little bit with it, so that you can see the vulnerabilities that are going on. A lot of them maybe you can recognize because we've talked about them. Like for example the integer overflow and underflow, where if you go below 0, you can end up on the other end on a quite high value. And yeah, like the reentrancy, we've also talked about that. That the contract can be entered in an unexpected way. There are a couple of vulnerabilities that I've marked in green that are now put into the compiler, so the compiler checks for those situations. So that's more difficult to make that mistake. So you have to, of course, look at the compiler error messages and warnings and do something with them. Yeah, some things are quite obvious, like if you have a return value of a function, yeah, of course, if that could return an error code, then you should check that error code. But that's just basic programming rules that you normally should do. Yeah, there's about 33 items on that list, so it's quite a long list. But if you look at them, yeah, every now and then you start recognizing more and more of them. Here one I've marked red, which is a quite important one. If you use the delegate call, you might remember that we've talked about it with the proxy thing. It's where you delegate your call to another smart contract, and that smart contract can use your own variables. So that's pretty dangerous because that can change all your checks and whatever you've made in your own smart contract. So if you use delegate call, you have to be very, very careful and be sure that you can trust the contract that you are calling. So you can at least use like a whitelist to make sure that you only call contracts that you know about. This one, for example, is the randomness from the chain. We've also seen examples like with the casino where we created randomness from blocks on chain, which wasn't very secure. So that's obviously also on the list with the possible solution to use Oracle, which we already discussed about. Here are two more red ones, and that's writing to arbitrary storage location, which is also of course dangerous. That can happen if you have an array where you're not very careful about the bound. So if you write outside your array, then you can access the variable that's before you or after you. That can also happen in other programming languages. But in Solidity that's especially dangerous, because then maybe you can override some kind of check or whatever that you've built into your contract or other variables. So this one to be very careful about. And something comparable is if you allow a jump or a function call where the address where you're calling to, that's a parameter, so that you can jump to an arbitrary address in your contract. So in simple contracts that wouldn't happen, but in more complicated contracts that could happen. So if you use functions as variables, you have to be very careful with that. It's best to just read through all those things and try to see if you can understand it and if it's obvious or not. And if it's not obvious, then have a look at it or ask it. Okay, now we know of a lot of things that could go wrong, and here's a sort of standard to list all the solutions that you can use. It's based on the OWASP standard. Has anybody heard of OWASP? Yeah, some have. Anyone taken lessons which are focused on security? Not yet? Okay, well, if you would take lessons based on security, probably they will mention OWASP. Security is a whole subject on itself, with lots of details which go far too far to tell all now. So and also more general security things to be aware of. Also when you're making smart contracts. But I'm trying to focus it now more what's really relevant for the smart contracts. But anyway, this is based on this standard, and these are all the subjects. So what you can do if you create a smart contract, you just take this standard and you walk through them and check each line, have a thought about it, and have a done what's told over there, and then if not, do it. It's a lot of details. It's a bit difficult to explain all of that. But one of the basic things is here to have a threat modeling, and that's that you are aware of all the things that can go wrong with your smart contract. And here's one example of an audit of a smart contract, where they also started with threat modeling to see what's going on with the smart contract. That was also one of the assignments to do, is of the smart contracts that you, or one of the smart contracts that you've made, to basically make a drawing of what's going on and to put in all the parties and the objects that you're using in your smart contract. So this is an example, doesn't have to look exactly like this. In general, you have parties that work with your smart contract. You have the smart contract and all the building blocks like maybe IPFS and smart contract and Infura and website. And if you know all those blocks, then it's a lot easier to see where things can go wrong. So always when I look at security, also I start with making a drawing of what's going on. Now, once you know a lot of threads, then you can compare them, and not each thread is as important as the other one. So here's a tool that you can use to compare threads, and you just fill in some questions over here, and you get a score of your thread, and then you can focus on the most important threads that you have. Just nice to know, and you can have a look at it and experiment a little bit with it, but we're not going so far now to put all the threads in something like this. But if you have a big project with large amounts at stake, then you would use something like this. A nice tool that exists that helps if you have large smart contracts, especially if they are built of multiple interconnected smart contracts, and you want to have an overview out of that and make a nice picture out of that. You can use this tool called Surya, so it makes a graphical overview of your smart contract. So there's also an assignment to install this and experiment with this, and to make a picture out of your smart contract. Just that you know that it's possible. Of course, the smart contracts that we have are so small that the pictures are relatively small. But if you have a large smart contract like for games or something, then the pictures are quite big. If you want to draw them by hand, it's quite difficult, but this makes it a lot easier. So you install it like this. You install it with npm for this one, and you also need this program called GraphViz to make a visualization out of that. And then you connect those two to create a picture. And then you get these kinds of pictures out of that. If you have an example smart contract like this, you get these kinds of pictures. The second thing for security is access control. As you know, in a smart contract, the smart contract is quite powerful. You can transfer it and change values and all those kinds of things. And you want to protect it, that only people who you want to be able to do that are allowed to make changes. So basically you have an access control mechanism within your smart contract. You would normally have that also on a website. In a website you normally also have something like a login, and based on the role that you have in the application you can do certain things. In the smart contract, you have to build it yourself and do something similar like that. And there are, I've here 3 examples of access control mechanisms, from very simple to what's somewhat more elaborate. The simplest thing is the one with an owner. We've talked about that one before with the modifiers. So you create your owner when you use the constructor to initiate the contract, and then you remember who is the owner. And then later on, with other calls, you can check if it's the owner who's doing that, and then you have a very simple, basic access control mechanism. So this one is the simplest one. You can make it somewhat more complicated, where you use a white list, so that you don't have just one owner, but you have multiple people or addresses who can do something on your smart contract. And then you just make an array actually of addresses who can do things. And you combine that also sort of with an with the previous one, the owner thing. Here you have in the constructor you create a whitelist with the first address who can update the whitelist, and then you just add members here with this function to add more members to it. So this sort of builds on the previous one to make it more elaborate. And then the third one is even more elaborate. When you if you look at this one with the whitelist, then everyone within the whitelist can do the same things. So that's for simple contracts it's okay, but for more complicated things you don't want everybody to be able to do the same things. And there you can use roles, the so-called role-based access control, RBAC for short. And there you define roles, so you can add a role, and in that role you can add members to a role. You can define the roles whatever you want, and then you can connect functions to a certain role, so that makes it more elaborate actually. So anybody heard about role-based access control? Yeah? No? Okay. The actual role-based access control is a quite general mechanism which is present in a lot of applications. If you look at any application, usually there's something like this built in. So you have maybe an administrator, and you have a user, and you have whatever, lots of functions. So this is also an assignment into smart contracts that you build in an access control mechanism. So there's one of those three. So if you have a very simple smart contract, you take this one, and if it's more elaborate, you take one of the other ones. Maybe you already have it, but if you don't have it yet, then the idea is to build something like this. The next part is about the data that you put on blockchain, and then especially about confidential data that you, of course, everything on the blockchain is public, so you have to be very careful about confidential data, especially if it's privacy related data, GDPR related data. There are lots of discussions about what privacy related data can you put on the blockchain, and in general you have to be very, very careful to put that on the blockchain. But there are some things that you probably can do. It's not really definitive decided that it's okay to do, but it seems that certain ways are allowed and other ways are not allowed. So if you take some personal data, at least, yeah, you can, when you design your application, you should think about it. What you would normally say, well, why don't I just take my data and encrypt it and put it on the blockchain, or hash it and put it on the blockchain, like these two possibilities. But they are not considered good enough by lawyers and a lot of people. Because if it's encrypted, and it might be possible to decrypt that in the future, because it's stored on the blockchain, it stays there forever. And in the future the encryption mechanism could be broken. So that's, yeah, you never know when it could be broken. And maybe the key can be discovered after some time, and then if all, for example, your medical history is on the blockchain and yeah, the encryption is broken, then suddenly everybody knows that. So that's sort of tricky. Then, well, you could say, well, I just hash the data, and the hash is just a one-way function, and it's, yeah, that's pretty difficult to reverse engineer. But that's not entirely true. You have a table, because if you hash the data and do that multiple times, then every time the same data is hashed to the same other value. So you can use that hashed value to link pieces of data together. So yeah, there you can maybe find out who has done certain action. And for example, if your name is hashed and your name is put on the blockchain, and you've done maybe 20 actions, then 20 times you have the same hash on the blockchain, and then people can look up those hashes and match those 20 times and see, well, it's 20 times the same hash, and then connect all of those actions together to the same person. So that's, yeah, that's why it's not good enough. So that's what they call the linkability risk, so that you can do pattern analysis and, yeah, find back information. And there's also one risk they call the reverse engineering risk. If you take a hash of something that's not so big, like maybe a telephone number, then you can just run a program and test out all telephone numbers and compute the hashes of all telephone numbers there are. That's doable because there are not that many telephone numbers. And then you can make sort of a lookup table and find back the telephone number that corresponds to certain hashes. So if you use a hash, then you have to be careful it's not on a small piece of data. What you can do, and what is the solution if you go to more like this side, if you take a hash and you put more data into the hash, or more data into the input of the hash. So this is the so-called salted hashing. So you put some salt, some random data, and then to the data, and then you hash it, and you take, every time you do it, you take a different piece of salt to add to it, and then you get every time you get a new different hash. So then you cannot use this anymore because every time it's different, and you also cannot do this anymore, also because it's different all the time. So that's a solution that works quite good. And that seems to be an allowed way to, also from a GDPR standpoint, to put or to link privacy-related data to the blockchain. So if we go back to this one, so that not use a normal hash, but use a salted hash. So a hash with additional data on it. And a variation of that is called so-called commitment. And yeah, commitments are often also hashes, so this is quite close to each other. And commitment, that we've seen that with the commit and reveal for random data. So you can do that if you want to put random data on the blockchain, then you, for a casino for example, first you do sort of a hash of that data, and then later on you reveal the real data that your real random number. So the first thing that you put on the blockchain is called a commitment. So that's often done by a hash, but it's not always done by a hash. There are other ways to do that. So this is a more general term. And an even more general term is the zero knowledge proof. Yeah, technically that also uses things like hashes, but it's more elaborate. And then a zero knowledge proof is a way to prove something without telling the original data. So I'm not going into that, but just that lately you hear this term more often, and if you want you can Google it and look up what it is exactly, but just that you know, if you want to do something like that, you can research it further and look into the zero knowledge proof. So this area is a no-go area, but this is okay, probably. Okay, the next area is the communication, so that's the connection to other smart contracts. And that's where you have to be very careful if you want to call other smart contracts which you don't trust completely and you don't know, and lots of things could go wrong over there. So you have to double check that very well and be very aware of that. Yeah, the arithmetic is the one with the overflows, underflows. So that's also where you have to be pretty careful. This is more a general thing which is true for any application that you make, that all the inputs that you get from the outside world, from function inputs, you can never rely on that it's okay. So you always have to check all your input values to make sure that nobody enters an extremely large number or a large string or a negative number or whatever. You cannot assume that the values are correct. So you have to assert that and check for that. Yeah, the next area that you have to be careful about is the gas usage. So you need gas for all your actions that you're doing in your smart contract. And if you're not careful, then you might need more gas than is available for your smart contract. For example, if you have a loop over an array and the array gets bigger and bigger and bigger, then the loops takes longer and longer and longer. You need more gas, and then finally you could end up in a situation where there's not enough gas, or if it's even impossible to supply enough gas because you're reaching the upper limit of the amount of gas. So this is also an area you have to check. Yeah, this is more a general area, the business logic. So that's the logic of your application. That's also with any application. You have to, of course, design that quite good and think about all the situations that can occur. that you, for example, cannot withdraw money if you don't have the money or if you're not allowed to withdraw the money. So it's difficult to say general things about it, but it just means, yeah, make good drawings and think about it. Yeah, the next thing is the denial of service. Smart contracts are pretty difficult to upgrade, so if you have a bug in your smart contract, then you could be stuck with it. And especially if it's a denial of service type of thing. If you make one mistake with your asserts and require and those kind of things, yeah, maybe there's no flow through your program logic that works, and then you're just stuck. And if you cannot upgrade it, yeah, your program just doesn't work anymore. Yeah, this one is about tokens. Yeah, with tokens, of course, it's an external library with some rules that you have to apply. So, yeah, you have to understand the rules of the tokens quite good when you use them and conform to the rules. Code clarity is, of course, pretty important. That is quite helpful to understand your own smart contract, and also that other people can understand your smart contract. In one of the next lessons, I will also explain about ways how to document your code better. We have really focused on the clarity of your code, but the smart contracts, they are yeah, sort of the centerpiece of your application, and they should be very easy to read and very, yeah, well structured. Now, test coverage, that's the subject of the next week. In smart contracts, even more than, of course, every application you have to test pretty well. But on smart contracts, it's just, yeah, extremely important to do that. So you should test everything in all situations within your smart contract and build unit tests and run them every time you make an update on that. So next time you're going to learn how to do that. But yeah, here's just on the checklist to know that that's important. Okay, well, these are all the areas of the security checklist. So it's a pretty long list. It's a bit boring to hear about it, I guess, and to tell about it. But yeah, you can just use it as a checklist and see in your smart contracts, yeah, if you thought about it. In the afternoon, I will be telling about key management. So these are the assignments. There's one assignment for key management. So we will talk about that this afternoon. But for this morning, there are 3 assignments. So one is to build something with access control into your smart contract. One is to use the Surya application to make a drawing of your smart contracts. And the third one is to make a threat model drawing of your application. Is it clear? That is expected. Okay. Are there any questions so far about the security measures and the weaknesses? Okay, well, just dive into it. So that's of course also important to have a look at it and see it for yourself and experiment with it. And if you have any questions, of course, let me know. Yep, we're running again. Okay, we continue with security and now especially the part of key management. And key management, that's the management of the keys, so your public private keys of your wallets, which is of course pretty important in Ethereum. And you have it in two places, at the end user side and of course on server side. So if you have a server side application that you make, you also have keys which you have to manage. So I'm going to show a couple of basic principles, and then the idea is that you sort of think about it, and the assignment is to make sort of a recommendation for the application that you make for the users of the application, what they should do for key management. So basically you have to choose one of those methods to use. Well, the first and most straightforward thing is that you take the passwords, like for example that you have in MetaMask, and you store those in the password manager. So there are lots of different password managers to use. Does anybody of you use a password manager? Yeah? What have you? I've been using it for quite a while because I just have far too many passwords to remember it all. It's just zillions of passwords. But you can use that to store the PIN codes and the pass phrases for the recovery phrases for your smart contract, for your address. And you can also, that's what I do, for example, store the addresses that I use also, because I have lots of wallets all over the place, and it's quite easy to forget which wallet you have and where you have them. And if you forget your wallet, well then of course whatever is on the wallet is also gone. So that's also a piece of the management to do. Okay, a simple thing to keep your wallet is a so-called paper wallet. So that's basically writing down or printing down the private key or the recovery phrase of your account. Then it's not on the internet, so it can be stolen from the internet. But if it's paper, you have to be careful with your paper, and if there's a fire, then your paper can get burned. Maybe it's good to have multiple copies of your paper. But it's a useful thing to do. I also have one of my key phrases I've also written down and put on paper. So that's a good thing to do. But you have to be, of course, be aware of the risks. And there are of course plenty of risks. When you create a wallet like that, usually you use a computer to do that, and that computer could be connected to the internet. And at that moment, somebody might already steal your keys. And if you just use a random website on the internet to create a wallet like that, then you're also depending on the website. You never know who has created that and how secure that is, and how random it is. If your wallet isn't created sufficiently random, then it's not a good wallet and somebody can steal it. Now, if you take that paper, if you really think about the paper version, then it can get burned. And then there are, of course, solutions to do that and do something that's not on paper, but that can withstand fires or those kinds of things. And several people have created several solutions which are made from steel. Here's one where you have a grid and you punch the letters and numbers into it. And here's a solution where you put certain pieces on a metal thing which also represent values. So it's a funny way to do, but if you have something like this and you don't remember exactly how it works anymore, then it's not much use. And this is just basically paper, but then made from metal. one of the solutions also in use is to use so-called air gap, so that you don't connect your wallet to the internet, but that you do that keep it on a separate device and transfer the data only via a non-electrical way, so via a QR code, for example. And somebody has created something called AirGap, or the website is airgap.it. It's an application that you can put on your mobile phone and then do all the registrations on your mobile phone and exchange via QR codes. So that's useful if you have a large amount of ETH on it. If you have a couple of million, then maybe you don't want to keep it online, but you want to keep it on something like that. But of course, if you want to do a transaction, that's pretty cumbersome. So that takes a lot of effort. So it could be good for cold storage, that you maybe once a month transfer some money around or ETH. But the large exchanges, they have solutions like this, because exchanges are hacked quite frequently. So most of them have at least 80% of their money on an air-gapped kind of thing. Now then you have the hardware wallets. Something like this one. This is a frequently used example. Has anyone seen it?
Is it Ledger now?
Yeah, it's Ledger. These things are not that expensive, maybe like 50 euros or something. And there are of course different versions of it. Yeah, but it doesn't really solve all the problems because you have a PIN code to access that thing. But yeah, and of course the PIN code you have to write it down somewhere. And you can lose your PIN code or whatever. And you also have a recovery phrase for that. That's of course good. If the thing breaks down, then you would lose all your keys. But if you write down your recovery key and somebody steals that, or if you put it in email or whatever, then you still have a problem. And I also thought that in those devices you just use that to sign a transaction or whatever. But when I was playing around with it and made some examples, then I noticed it's possible to retrieve the entire key from a device like that, so the private and the public key. And if you of course have the private key, you can just easily retrieve that from that, then yeah, it's still not very secure. But I think it's a relatively good solution. Oh yeah, by the way, you also connect it via a USB cable to your PC, so that is also tricky. Then maybe that could be intercepted, or the software running with the USB cable could be intercepted. Now, how can you use that? For example, with MetaMask, there's an option to connect your hardware wallet. And yeah, you have to plug in your key, and you see some pop-ups, and then finally it says unlock your ledger, and then you can choose one of the accounts that you want to use from that. So a device like that supports multiple accounts and also multiple currencies. So you can use Bitcoin and Ethereum and lots of other things from it. I've made some JavaScript code to interact with such a device. If you happen to have one, then you can try it out. But it's not really assignment, but just to know that's possible. And yeah, basically it's pretty straightforward. You use a few libraries and you can open a connection to it. And you have to unlock it, of course, and put in the PIN code, and then you can interact with it. And here you can retrieve an address out of it. And when you retrieve an address, you specify a specific path, and this path corresponds to Ethereum. And if you put different values over here, then you get the BTC version or ETC or whatever. In one of the next lessons we'll dive into this further. But just if you see something like this, it has to do with Ethereum. Well, here you can get the key pair, and I'm showing here the address, but it also contains the private key in this variable. So that's tricky. Yeah, you can also, this one is relatively low level API, which is created by the ledger creators. And on top of that, you can also use the web3.js interface. You need a few more lines of code, and then you can just use the normal commands here, the web3, and the web3 get accounts command, and you just get the information like that, and do all the signing and whatever with your normal API that you know. Yeah, and the previous example is just directly JavaScript, but you can also do that from a website, and that's the same code as before. The only difference is this line, is a different library that you use, but otherwise the code is exactly the same as before. And it turns out that there are even two versions of web interface. You have now the web USB, that's I think a newer standard, and this one, the UTF, is an older standard. So they both work, but this one is deprecated, so you're not supposed to use it anymore. And this is the new one. But the only difference is just this keyword. And the user interface also slightly different. Here you see a pop-up with the device that you want to use. So you have to click on the device that you want to use. Another type of hardware device is HSM. I'm not sure what the abbreviation means, but it's usually used on servers, these kinds of hardware security module. It is. So it's something like this, a USB connection, and you connect it to your server. And you also have smart cards, which you can also connect to your server. So they sort of work the same like the other device, but this is more that you keep this connected to your server. You also have different APIs to connect to it. And for example, in the GET, the node, they have implemented, I don't know, they implemented the ledger interface, but they also implemented other hardware devices. So if you connect the ledger to your PC and you start GET, then you see that it recognizes the device if you have enabled it in the configuration. But they also have support for these types of hardware. Yeah, the next thing that you can do that's in a slightly different dimension is that you use a multi-sig wallet. If you show a picture, that's normally when you have the blockchain and you want to interact with it, then you would normally do it from your normal account, directly interact with the contract that you want to interact with. But you can put another contract in between, and that contract can do the calls that you want to do for you. So you channel it through this contract. but you can, because this is a contract, you can add more functions to it. So you can say, well, suppose I want to sign a transaction over here, and I'm only going to sign it if at least 2 persons, for example, are okay with it. So you have to do then 2 calls from 2 different persons, and this one remembers who has signed it, and then only after at least 2 have signed it, then it signs this contract. Or you can do N out of M, so another amount. Or you could also use the input of an oracle to do some calculations with it. So, for example, you could connect an email to an oracle, so that you can have an approval via email to do the transaction. So the transaction could maybe send first an email via an oracle to somebody else says it's okay, sends an email back, this is captured again by the oracle and then put in here, and only then it continues. So you can make far more advanced things. You can even chain it together, so you can put a contract before this one and maybe even further contracts. So you can make it as complicated as you want. And here I've listed a few functions that you can do with that. So you can do something that you have n out of n signers to get something signed. Or you can have something with a time-locked transaction, that transaction cannot done before a certain time or after a certain time, or only in between certain times, that you can only do it in weekdays and not in the weekend, or the other way around. You could put limits on it, that you can maybe transfer only 1 ETH per day and not more than that. You can freeze it, or do something like a deadman switch. You have to unlock it every month or whatever, and otherwise it just stops. And you could do something with your inheritance. Suppose one day you die and that you want your ETH to be transferred to somebody who can inherit it from you. Then you can make something automatic in here. If you no longer use the wallet anymore, that after a month or a year or whatever, the ETH is transferred somewhere else. And this could also be useful if you maybe forgot all your other methods to access the wallet. And if you do something that after a year it's automatically transferred somewhere else, then you have your ETH back. You could also, in combination with the Oracle, do something with multiple authentication, like a 2-factor authentication, so that you not only do it in MetaMask, but you also get a pop-up or whatever on your mobile phone and have to say it's okay also. There are lots of things that you can do. What you can also do is that you pay gas fees in a different way, so not with normal with ETH, but with other ways, or maybe that you have ERC tokens, ERC20 tokens, and that the contract exchanges those ERC20 tokens for ETH and pays the gas with that. And you can also batch transactions, so combine multiple transactions, and then only when you have maybe 20 or whatever, continue the transaction on the blockchain. Yeah, and you can do the recovery methods. So after a certain time or via a central entity. There are companies who sell that as a product, where they say, well, you have a solution like that, and if you want to recover it, then you can send me an email and we can recover it for you. Or you can do a social recovery method, that you give maybe 10 of your friends a piece, a key to unlock your contract in case you forget your key. So I think this is the future where it's going to be heading, because the way it is now with MetaMask is just too easy to forget your keys and too easy to make mistakes. So for the general public, the current way is just not good enough. So this looks more like you have it with current banks and whatever. So I think this will be where it's heading. Okay, so these are all the key management methods that I've collected. Any questions about it? Okay, unless that you sort of think about this and think for your smart contract that you're making or your application, what would for your users be an ideal way to do key management?